This problem says a 5 kg box rests on a horizontal surface. The coefficient of kinetic friction between the box and the surface is the kinetic coefficient of friction is 0.5. Mu k is 0.5. A horizontal force pulls the box at constant velocity for 10 centimeters. Find the work done by the applied horizontal force, the frictional force, and the net force. All right, so let's do a diagram. Okay, so here's the force of gravity, which is equal to mg, and the normal force is equal to the force of gravity. Here's the friction force, the kinetic friction force, and the box moves with constant velocity. Okay, so here's the horizontal force, and okay, so the normal force is equal to mg, since the box is not moving in the, this force is balancing that, and the friction force is mu k times the normal, mu k times the normal force, which is equal to mu k times mg. Now, since the box is moving at constant velocity, this force must equal that force, the horizontal force. So that means F equal to F, which is equal to mu k times mg. So now let's look at the work done by the horizontal force. Here's the force, here's the displacement, and I imagine there's a typo here. It's probably not 10 centimeters, it should be 10 meters. So we'll change the problem and make that 10 meters. Okay. 10 meters. Alright, so the work done by the force is FD cosine 0 degrees, because the angle between F and D is 0 degrees, so this is equal to mu k mg times d, and cosine 0 is 1, so this is 0.5 into 5 into 9.8, and we've changed that to 10 meters, so okay, maybe I'd better write all of that. 0.5 into 5 kg into 9.8 meters per second square, and I've changed the distance to 10 meters, so this is equal to 245 newtons. So the work done is 245 newtons. The work done by frictional force, okay, let's add a page. So on that box there's the frictional force, and there's the displacement equal to 10 meters. So work done by friction is Fk d, and the angle between the force and the displacement is 180 degrees. Okay, and as we keep saying, friction always does negative work, so this is minus mu k mg d, and you can see that this number is exactly the work done by this force, except that it's negative. Okay, so the work done by frictional force is negative 245 joules. And the net work done and the net force on the box. Well, we'll calculate the net work done as well. Here's the force of gravity, here's the normal force, here's the friction force, and here's the applied force. since it's moving at constant velocity, since the object is moving at constant velocity, the net force on it is 0. The acceleration is 0. So that means Fn plus Fg plus F plus F equal to 0. And we know that, we already knew that the normal force cancels that. The horizontal force balances the friction force. Okay, that finishes this problem.